Okay, everyone, a few reminders. It's a new semester. If you were not in the habit of listening to the video last semester, change that habit and listen to it. Don't just do scribble scratch and get some things on the paper, but you don't understand anything. And you really should have, in fact, I'm going to make have the ebook open to the homework assignment as you do the work, and look at the original problem and read it carefully. So, I mean, yeah, you might get something out of just watching me do the problem, but I don't show the original problem for very long, and it's probably going to benefit you if you read that problem carefully and you're trying to figure it out, and then kind of using the video more as a support or as a way to check your answer. If you're just kind of blindly watching me do a problem and not really putting a lot of thought into it, you're probably not going to get a lot out of it, and then you're going to get frustrated when you don't understand things. So have that ebook open and make sure that you draw all diagrams, and there's a few diagrams for these problems in checkpoint number 4. Okay, so we are doing checkpoint number 4, which, if you're looking at the ebook, which you should be, if you go to that left tab, it's at the bottom. It's after all of the chapters, and it'll say checkpoints. So go to checkpoint number 4. These, when we get a checkpoint problem, that means if there's one like this in the chapter, that means there's going to be questions like this on the test, even though this is not what our chapter is about. So ideally, we are doing all the problems from the homework, which unfortunately we are not doing. But if we were, in an ideal world, by the time you got to that checkpoint question, you would be able to do it. That's the goal. So the checkpoint was 486, and there are examples in the checkpoint in the back of the book. So if you look at those examples, it shows you how to do that checkpoint problem, which, if things go as planned, this is going to be part of a team quiz this week. So if you are listening, you will know that those answers are in the back of the book. Okay, so today we are doing checkpoint number 4. And we're starting with evens today, and we'll do odds next time. So for number 1, we have 2y minus 1 over 15 equals y over 10. So I think a lot of students just think this is some kind of trick, but the reason that cross multiplication works is, for example, if you have 1/2 equals 4 over 8, if you have two equivalent ratios, this is called a proportion. And if this is a true statement, it's a fact that this cross product will equal this cross product. 2 times 4 is 8, 1 times 8 is 8. So what you're saying here is, something divided by 10 is equivalent to 2y minus 1 over 15. Well, if that's a true statement, this cross product, 15y, will equal this cross product. Okay, so that's not just some random little trick that we do. It's based on the fact that if you have two fractions that are equal to each other, if this reduces to this, then this cross product, this numerator, this denominator, multiplied by this denominator, is going to be equal to this numerator multiplied by this denominator. Okay, so then we get 20y minus 10 equals 15y. I have y's on both sides of my equal sign, so I always say get rid of the smaller one, which is going to be a little different here. In fact, if you want, we could move this over to the other side first, it really doesn't matter. I could just get rid of the smaller 1 by subtracting 15y from both sides, and that would give me 0 equals 5y minus 10, and then move the 10 over to the other side, which would give me 10 equals 5y. Divide both sides by 5, so y equals 2. You could take that and plug it back in and see if that's correct. I'm going to just do that quickly in my mind. So 2 times 2 is 4, and 4 minus 1 is 3. So if I plug in y equals 2, I get 3 for the numerator over 15, and then 2 over 10, and 2 over 10 reduces to 1 over 5. 3 over 15 reduces to 1 over 5. So that is correct. For number 2, we have, what are we doing? I just did an odd one. I meant to do an even, darn it. Okay, well, let's do number 2. 5 over 8 equals x over 100, and then you could just save that other one for maybe get a new sheet of paper and do number 2 on a new sheet of paper. Sorry about that. Cross multiply, we get 5 times 100 is 500. 8 times x is 8x. Divide both sides by 8, so 500 divided by 8 is 62.5. Number 4. Okay, cross multiply, that's going to give me 28x equals, now you could skip this step and just write the final answer. I'm writing it out in case you need it. 5 times x would be 5x. 5 times 2 would be 10, so it's going to be 5x minus 10. It's fine if you want to not write this and just go straight to this. X is on both sides. Get rid of the smaller one, so I'm going to take away 5x from both sides. So 23x equals negative 10, and then I'm going to divide both sides by 23. So x equals negative 10 over 23, and you can just leave it like that. That's not going to be a nice non-repeating decimal. Okay, evens. Number 6. 1 over t equals 5 over t plus 1. So I'm going to cross multiply. That's going to give me t plus 1 equals 5t. I have t's on both sides of the equal sign. Which one is smaller? T is smaller than 5t. So I'm going to subtract t from both sides. That's going to give me 1 equals 5t minus t is 4t. T is being multiplied by 4. Opposite of multiplication is division. So I'm going to divide both sides by 4. So t equals 1/4. Number 8. Okay, so this is just the mechanics of solving a proportion. More effort is going to be needed when you are setting up the proportion from a diagram, and there are 3 problems like that on your next test. So I'm hoping that you're saying to yourself, wow, this is easy. I know how to do this. Why are we doing these? If that's the case, you're in good shape. And let's just make sure you can take 2 similar triangles, and set up this proportion, because once you get the proportion set up correctly, it is pretty easy. Okay, and even if you mess up on the algebra on this process, I'm going to give you most of the points for setting it up correctly. 6 times 3x is 18x. 4 times x plus 1. So I'm going to distribute, which is going to give me 4x plus 4 is 18x. X is on both sides. 4x is smaller than 18x. Subtract 4x from both sides. So 14x equals 4. Divide both sides by 14. So x equals 4 over 14, which reduces to 2 over 7. Okay, number 10 says, if 300 vitamins cost $5.75, what should 500 vitamins cost? So 300 vitamins cost $5.75. And then it says, what should 500 vitamins cost? So I'm going to put 500 on top, x on the bottom, and I'm going to multiply 500 times 575. $300 times x would be 300x, and then I'm going to divide both sides by 300. So that is 9.58. Okay, number 12, if a basketball player made 72 of 85 free throws, how many free throws could she expect to make in 200 attempts? So the player made 72 out of 85 free throws. Okay, so these are the attempted free throws, and that's how many she made. And then it says, how many free throws could she expect to make in 200 attempts? So maybe I should put free throws on the top and attempts on the bottom. So 200 attempts can she expect to make? So we're going to do 72 times 200. $85 times x, divide by 85. So she can expect to make about 169. Okay, number 14, the length of a rectangle is 4 centimeters more than the width. So let's stop right there. Let's draw a rectangle. Length, width. It really doesn't matter which one you call the length and which one you call the width. I usually make the length the longer side. The length is 4 centimeters more than the width. So if my width is W, my length is 4 plus whatever W is. If the ratio of length to width is 7 to 5, determine the dimensions of the rectangle. So ratio of length to width is 7 to 5. So length to width is 7 to 5. Over here, the length is 4 plus W. That has to go on top because I put length on top over W. You have to have one variable. You can't have L and W in your proportion because 2 variables is an infinite amount of solutions. One variable, either L or W, is going to be one solution. Cross multiply. So the hard part here is setting this up. And that's why it's so important for these problems that you are looking at the problem and you're making that connection and you're not just watching me do that. If you're trying to figure it out for yourself and using this as kind of a guide, as a support, that is better than just kind of watching me do it and not thinking about anything. So 7W equals 5 times 4 would be 20. 5 times W would be 5W. So 20 plus 5W. I've got W's on both sides. Subtract 5W from each side. So divide both sides by 2, and W equals 10. So if this is 10, this must be 4 plus 10 is 14. Okay, this is going to be a nice short video. Number 16, in the diagram at right, triangle ABC and ADE are similar. There's one just like this on the test. If AB is 6, BD is 4, BC is 7, what is DE? Okay, so it even tells you, draw two separate triangles and label the dimensions. So you have to draw the triangles separately. And once you do that, it's really not that bad. The ones on the test aren't too bad either. There's a lot of resistance to drawing triangles separately for some reason. I think it's just being a little lazy. Don't be lazy. Okay, AB is 6. BD is 4. Okay, so BD, this is 4, this is 6, so then AD is 10. BC is 7. What is DE? Now, you can probably do this without writing out all the similarity statement, the ratios, and all of that, because these are oriented the same way. And I'm going to skip that here because the ones in the test are pretty easy to set up. I'll do it for the study guide video, but for now I'm just going to say, okay, I know that, well, it told me that I'll write the statement, and let's just make sure we have the right sides going together. Even though you can kind of look at it and see it, doesn't hurt to check. Okay, I know AB corresponds to AD. Just guessing here. So 6 is to 10 as, and then I know BC corresponds to DE. I'm not just looking at this and making a guess. Because of this statement, because of the order of these sides, I know that BC 7 corresponds to X. So the biggest mistakes I see is people will just, well, and you can use a scale factor. You don't have to do it with a proportion, but there is one in the test where it's going to probably, there is one where you almost have to. I mean, people could say, oh, I can do it without, and you probably can find a way. But it's just easier to use the proportion on one of the ones in the test. So I think it's like the next one I'm going to do. So it doesn't hurt to practice setting up a proportion with one that is kind of easier. Okay, here, this part's easy, right? 70 equals 6x. So x equals 70 over 6, which would reduce to 35 over 3, which is 10 and 11 and 2/3. I'm not as concerned about this as I am about setting it up correctly. So if you're rusty on that, we're going to do another set of 10 of these questions for the next homework assignment, and just keep practicing with these or with the ones that are on the study guide. Okay, 18, draw the two triangles. We've got two similar triangles, and it's showing us that all of the angles are the same. Okay, so we know that this is just a dilation of this. And again, I'm not going to go through the whole statement and proportion because we can see what angles match. These two triangles are oriented the same, so then you probably are going to get the proportion right without doing all of that. So I know that y plus 5 corresponds to 5. It's across from this angle here, which matches this angle here. So I'm going to say y plus 5 is to 5. I could have done this 5 over y plus 5. It doesn't matter. But if I set it up like this, with the triangle on the left on top, then 14 has to go on top. So this is my left triangle, this is my right triangle, this is my left, this is my right, 14 over 4. So then that's going to give me 70 equals 4y plus 20, so 50 equals 4y, so y equals 50 over 4, which reduces to 25 over 2, which is 12.5. right, number 20, draw the picture. Now, it's been a little while since we've done really any work with similarity, other than a few homework problems here and there. And most of them are set up like this, and there's one like this on the test. So I'm going to use some tracing paper here and refresh your memory. You've got, what kind of lines are these? These are parallel lines. So you've got parallel lines cut by two transversals. I'm going to focus on this transversal here. So if my lines are parallel, if these two lines are parallel, then I know these four angles here are going to match these four angles here. So this angle is in the triangle, and it's the same as this angle, which is not in the triangle, and it's the same as this angle, which is in the triangle. It also matches this angle right here. So if you use the tracing paper and color in which angles match, then you really don't. This is one where it's easy to mess it up if you don't get the right angles. So I know this angle matches this angle. Okay, these are going to be the same. These are vertical angles, so they're equal, which means this angle is the same as this angle. Okay, now from there, I'm just going to look at what angle the side is across from. X is across from this angle. So I'm going to say X is to 8 because 8 is across from this angle. This is my left triangle. This is my right triangle. Then I'm looking at 8 in the left triangle, which is across from this angle that has 3 marks on it. So left triangle goes on top. And then what side is across from the angle with 3 marks? 6. Now it's very easy to mess this up. Another strategy would be to just take some tracing paper and put all the information from one of the triangles on that diagram. Okay, and then I'm going to match up the angles, which isn't going to be perfect. Let's see, I could have just rotated that, I think. Yeah, okay, so if I just rotate it, I see 8 corresponds to 6, not 4. X corresponds to 8. That one's easy to pick out. But sometimes people will mess this up right here and put 8 corresponding to 4. So there's a couple of strategies there. That's going to give me X equals 64 over 6, which reduces to 32 over 3, which is 10 and 2/3. Okay, that's it for checkpoint number 4, evens.